Hello, and welcome to how being a JavaScript CTF challenge creator / alleged war criminal has helped me at reverse engineering. Just as a point of interest, this is only for JavaScript-related purposes. I am not a war criminal in other areas of the world. I have not actually committed any war crimes. And just before I start, is there anyone here under the age of 18? Because I do know it is marked as a PG talk, but there is a certain name of a certain thing that does include a swear word, and I'm going to be using it repetitively. Who am I? I'm Maya. I am a vague person of vague description. A brackets employee at a brackets company, and I do a bunch of things. On the side, I used to do studies. I've thankfully escaped the world of academia. I deal with some things like various communities. I help them, they help me. They help me conserve what remains of my sanity. I do CTFs, I do conferences, and I click on the button too early. And I also do stupid fun things such as give this talk, which was not greenlit by my employer. But also, this is why they're not paying for my ticket. So let me give a little bit of context, because you get someone here talking about being a war criminal, you might want a bit of context. So I do really enjoy a good CTF as a player. Like, I've played in a few CTFs as part of a CTF team, so I'm not particularly good at it in any way, shape, or form, but I do enjoy it. So I've done some trace labs, which is no-sint capture a flag event, night CTFs, kernel CTF, square CTF, down CTF, etc. The name and the list goes on. I do enjoy CTFs because some of the challenges are a bit fun. Open source intelligence is something I really do enjoy as a hobby. Programming is also fun as a hobby. Reversing things that are vaguely cursed into things that are differently cursed is also something I do enjoy. I also contribute to CTF, so I've contributed to the AppSec Village CTF. I've contributed to a bunch of CTFs across not the world, but a few places. And I've built a few challenges, and building a challenge is always the same set of steps. It's just what you do with those steps that changes. So you always have your part where you have an idea, and it's usually a stupid one, and you don't know how you're going to get there. Then you're going to check if you can actually get there by any way, shape, or form, or if the technology is not going to allow you to do things that are that cursed. Whether you can actually reproduce this on another system, because it works on my machine, does not hold true for CTFs. If it's complex enough or not, because you do want some of the things you do to be approachable by people that don't necessarily have the exact same specific knowledge you do. The actual part where you engineer your challenge to come from an idea to a thing that'll work, and then documenting it, which is the piece people usually forget. And I've gotten a few reviews on some of my challenges. Some of them by people in this room. This may be a bit small, but spooky fucky wucky nonsense that is the visual equivalent of the output of a typewriter being kicked down the stairs, but it works, is a review by Mr. Scott McGreedy. So people don't necessarily like my contributions, but I'm fine with that, to be honest. So yeah. And I also do organize a few CTFs. So I really love the RA CTF team for kind of letting us stress test their platform. And by stress test their platform, I mean, we're expecting 300 users. Oh wait, 1,500 showed up. With live events, which work on live infrastructure, which works until it doesn't. So things catching fire, like halfway through or like at all times through, especially in the middle of the night, when people in other time zones are testing your things, is really fun. And we've had some very cursed things happen, such as things taking 30 gigs of RAM out of 16 gigs of RAM available. So that swap file was doing a lot of work. So yeah, that's that. There's also the moment where things go wrong. This is downtime. As an actual downtime of all challenges are inaccessible. This is another form of downtime. And I would show you the temperature graph, but when the temperature graph starts having holes in it, things are not going well. So yeah. as an organizer. And also really dislike cheating as an organizer. It's an issue I have. Many people have that issue. Coordination between teams, more players than is allowed, and fake accounts to farm for hints. The first two is usually something that you'll be able to suss out quite quickly. Well, all three actually. But the more players than allowed is really a point of fairness, because there's a lot of CTF teams, if you're on CTF time or on other things, where you'll see that a team has 20 members, and the team is registered for your CTF. And 4 people are going to log into your platform, but they're going to share their creds with 20 people. And that means you get people actually gaining an unfair advantage. And I don't like people having an unfair advantage. That's just why I make my shit hard. Which is not the best way of dealing with it, but. So, CTF challenges comes as a bit of something that requires some creativity. You can always do the random thing where, hey, it's a box, you need to use such and such CVE to get through it. Fine, that's fun. But I like to challenge myself as well, because being challenged is part of the whole thing. And there's multiple interpretations to being challenged. And that is one thing I'm banking on here. So Brendan Ike is a person, founded a few things, developed JavaScript, contributed to Mozilla, founded Brave, like the browser. And beyond those contributions to the field, is a vaguely stupid, horrible person. For reasons I'll not go into, but that are very publicly documented. Our computers make use of it a cursed amount of times per day. Your phones do. Operating systems do nowadays also. You have Wasm, which has a bridge to JavaScript. And this is technology that powers our everyday life. It is also very much well-maintained. ECMAScript is beautiful as a evolution of a language. It is something that will work. It is something that is vaguely standardized. The problem is the word vaguely. I'm not expecting you to read this. Everything that is read is something that is not supported in a version of a browser. So not everything will work everywhere, which is something that a lot of people have been devoting a lot of time to fixing. But at the same time, we're also adding more features and deprecating browsers and adding more browsers, adding more engines. So at the end of the day, it is very clunky as a language that is used everywhere. It would be nice if we had standards, but I think everyone here has seen the XKCD about standards. Yeah. So we have a thing that's called polyfills, which is supposed to at least be an abstract bridge from core JavaScript to what browsers can do. Well, yes and no. Because there's a bunch of polyfills which are developed by a bunch of people, which are fully open source projects, which are not necessarily funded. One of these polyfills is Core.js. Core.js is maintained by a person in Russia who has gone to jail a few times. They do not have any other contributors, or very few, no clear roadmap, and also no funding. So they do this on their off time and try not to go to jail. And also, it's Russia. They can't get funding due to the war. Because PayPal is holding their funds. A bunch of things are holding their funds. They can't extract crypto because, it's crypto. You wouldn't expect it to work well. Other things. So, it is a problem. If you want to read the entire story of this person, there's a link. But yeah, it is an issue, and it is an issue that is directly impacting everything we do in the industry. Well, in the industry. People that use JavaScript, which is a very small subset of the industry. But moving on. You were promised something cursed, vaguely adjacent to war crimes. I did promise you that. And let's talk about obfuscation. It's a very fun thing. Like you probably know about, let's say, invisible ink that, appears when you heat it, or that reacts to acid, like you squirt lemon juice on it, you have script. There's some very vague obfuscations, like you can hide things in other things, like a text in another text. I do enjoy zero-width space as a method of hiding data, because unless you're actually looking at the bytes that are going through, it's just text with no spaces, but you just start counting the bytes, it tells a different story. And you could, in fact, hide a lot of JavaScript within let's call it an esoteric version of JavaScript. So esoteric languages are usually languages that do something with a very small character set or by abusing certain features. But let's continue this small segue on obfuscation first, which is just hiding information on other part of information. So, for example, if I give you an RFC as part of a challenge, the bullshit RFC by the the shitpost working group. Don't ask. And I give you a fake RFC that describes how to use the Fibonacci sequence to hide information in a pigeonless manner. We are not RFC 1149 compliant, but whatever. IP over even carry. And I could take this picture of Bernoulli, and you'll see there's some corruption in there. This is actually steganography, where I've hidden data in there using an actual algorithm. This was a CTF challenge. This is fun. Red Panda. Red Panda has data at the end, somewhere injected in the middle. Won't appear in the image. It won't cause a fuzz. It won't cause a fuzz. However, you have base64 in there, and you have a flag. Very simple obfuscation. A lot of people will miss it because the simplest ways of just hiding information, people expect things to be hard. And people will just say, I'll never open a picture in a hex editor. Who would do that? Well, people miss the point. And this is why I asked whether or not there were people that were under the age of 18 in the room. Because I'm going to introduce you to the magnificent concept of JSFuck. JSFuck is a subset of JavaScript, which uses 6 characters. Opening parentheses and closing parentheses. Symbol plus, brackets, and the exclamation mark. With this, you can do anything in JavaScript. Literally anything. You can write out any single character in the character set, even in the UTF-8 character set, using these 6 characters. However, you may be required to use a lot of these 6 characters. That is the only counterpart. And you can evaluate any string using these 6 characters, which means you can get things to execute by just calling a string. Which makes things very interesting, because I can just say, hey, here's a long string, what will it do? Will it do alert1, or is it actually going to download a thing and install a thing on my desktop or operating system? Electron, until recently, I'm going to say 2018, had an issue where you could actually force Electron to install and run an app. Any executable, you could get it to run. And if I'm using JSFuck to download a thing and install it on a computer by putting it in the correct place, editing the path, doing all that stuff, and just, aliasing the path from CMD to something else, or any other common thing, I could get it to execute malware. So, few war crimes later. So, if you're not yet convinced, because I've told you things, I'm going to show you things. I'm basing this off on what I'm calling the new JSFuck standard. It's actually someone that went through and found out how to write the letter small c in JavaScript using these 6 characters. And it is actually longer than you'd think. And so that's Siguse at Mastodon.social that did that. So the contrast is going to change because just code doesn't look good black on white. I'm sorry. So the contrast is about to change. So, writing a number in JavaScript is actually very easy. You see, if you do plus exclamation mark open brackets, you get the number 0. If you do plus exclamation mark open brackets, you get the number 1. You gotta get to number 2, you double it up. Number 5, number 10, and so on. So, you see, this is already pretty easy, but this is not that interesting. And now the easiest way would be to do something like, in a normal language like Python, you would have some easy number, like to ASCII conversion. This does not exist here. The only way to do this would be with characters that you do not have access to, even in predefined characters. So, for example, if I used false as a value, or true, or undefined, or not a number, or whatever this is, I get access to more characters like F, A, L, S, E. Now not yet, actually, because those are just then values. I've not converted them to a string I can pull the value out of. But this, you can already start to see where I'm going with this. So I've not mentioned, but I'm Swiss, and that doesn't offer any more explanation. There you go. So we start with the plus opening parentheses that just calls a group, and will automatically convert any string to a number, as an actual number. You add the number 1, so far so good. You take false and you convert it to a string, and you get the third index out of it, so you get E. So you start to get one exposant something else. So 1E, a number. So we had 3, we had 0, we had 9. Okay, so far so good. And this does plus a string called 1E309. So this is 10 to the 308th power, which JavaScript does not consider to be a real number. So it calls it infinity. Except infinity, you can convert it to a string by just adding plus brackets. Like so. So if I had just a pair of open brackets, it's going to take what's in front of that and convert it to a string. Because that's how normal programming languages work. So 0, you just do 0 plus open brackets, you get the string of the digit 0. Same thing for 1, 2, 3, 4, 5, 6, etc. That's a bit cursed. So you can extract a few sequences of letters. So false, you take the value false, you convert it to a string, you get the 0th character, first character, second character, third character. Same thing with true. Far so good. And then you get with undefined. So the first character of undefined is N. Indices start at 0. Second character is D. And then you start to have two ways to get I. And this is where it gets fun. Is because you could either take undefined and prepend it with false as a string, and then get the 32nd character, was it? Now I'm having doubts. No. So you can either get undefined and get the 5th character, or you can do something a little bit cursed. Because you can do this. 1 plus bracket 0 is technically the string 10, but then gets evaluated as a number when you put it in brackets, as a slice accessor. You also have the letter N from that. So you have things like that. And we can go deeper. This 11E100, 11 to the exponent, to the 100th exponent, gives you access to a sign plus and a sign minus. Not minus, dot. Which does not serve us a lot nowadays. You can also build the word flat already. The word flat is very fun in JavaScript. You'll understand why in a second. You can also do the word entries with the character set that we've already built. So, I'm going to be entirely real. This is just hieroglyphics, and I'm not expecting you to actually read the code and understand what it's doing. I'm going to highlight areas. Green is what is interpreted as text. Pink is what is interpreted as a number, and we can just walk from there. If, however, you are colorblind, I am sorry. So I'm going to start translating a bit live. So if we go a bit deeper, that's just 1 converted to a string plus yet another 1. E100, okay, so far so good. This is just false first character, false third character, false second character, and true first character. Gives you flat. And entries, same thing. So far so good. Now what can you do with these words, magical words, is the next question. Well, if you open a pair of brackets and then you call, because functionally, an array dot a word in JavaScript is the same thing as an array, then brackets accessing the function that is at that word. Because that's how JavaScript was built. I'm not saying it's smart, but I'm saying it works. And then you call that function using the parentheses, and then you convert that to string. Then you get more characters, like opening brackets, which you already had. The space, capital A, capital Y, the O. You didn't have O yet. Things like that. Same thing with flat. The function flat. A function flat gives you parentheses, which you already had, curly brackets. We do love curly brackets if we're writing code. So, that's nice. We also have the space, very important, space. The word function as well. And curly brackets, this is where JavaScript gets a little bit weird. It's curly brackets, you could technically only access the first one, the opening one, with any definitive way to do it. Because depending on where you're interpreting your JavaScript, there may be a new line here, which will shift your indices. The only way to do this is to get the first one, do a bunch more cursed things, get access to the slice operator, and slice -1 to get the last character. But I'm getting a bit ahead of myself. So, you get that. That's pretty much how that works. And you can access parentheses. So, green is text. Pink is numbers. I'm not translating this yet. But you'll see here you have two groups, and this is what I was talking about. You have 1 and then the 3. And this is just index 13 without writing plus exclamation mark, brackets 13 times, because no one has the time for that. But people do have the time to write this, so, you know. So we get a few cursed numbers further down the line. Move that along. And this just translates to this, which doesn't help us any more than it did like 5 seconds ago. That's why I'm moving further. And this moves us to this. So the 8th character of function flat is the space. 13th is opening parentheses, closing parentheses, which technically we already had, but we didn't have as a character. We had it as a parenthesis in JavaScript. Plus sign, minus sign, just from the 1E101. Okay. Opening brackets, opening curly bracket. I got ahead of myself before. So you have a bunch of text, number, index 22, sorry. And same thing with this. So this gives you that. Which gives you that. Opening bracket, closing bracket, opening curly bracket. So you can start to see how we're building a language here. Like we're actually building the entirety of what could then be interpreted by the JavaScript interpreter without actually using any characters besides our 6 characters. So we can also get some other characters, fun ones. So using C, so the array object and then the other one, we can get flat and entries, right? Which lets us C-O-J and capital A. So C-O, those ones are quite important when you're starting to get into the funky world of constructors, which is how you build objects which can then be called. Capital Y and small case y. So you just take them from infinity, because that's how one does. So you just take infinity, convert it to string, pull the 0th and 7th character out of it, poof, I and y. They're not that useful, but you could do something with it. And you can go even deeper. There's a few more levels to this. So this, I'm starting to do things on the same slide now, because it's getting ridiculous, converts to this. So that is the first element, or the second element, of plus 11E100. So we saw that was 1.1 E101. And then we add a few numbers, but as digits after that. And this is this. And this turns out to be .0000001. This. This gives you 1E minus 7, which gives you a minus sign. I like the minus sign. This is not at all curse, but you get the minus sign. And this is where things go a bit out off the rails. I say a bit. It's been off the rails for a while. We haven't started with any rails. So this is this. Does anyone want to take a guess from context what this is? I did mention it before.
It's code that makes you cry.
Yes. But also. Anyone have any clue? Wager, I guess?
Constructor?
Yes. I think. Yes. Constructor. This is how you get a constructor in JavaScript. Or JSFuck. So it is getting very cursed. But functions, which is how you use constructors, are very fun. Because you get access to Boolean, which is a capital B. Not that useful. Number. Not that useful either. Except for maybe the M. String, which is very useful for your toString function. Because now you don't need to write the whole string of string. You can just call that. Which might be worse. Not entirely certain. And then function. This one is also very fun. So if you do this, you start to see, so that's the number constructor at the 12th position. This is the number constructor at the 11th position. This is false plus the string constructor at the 15th position. This is the Boolean constructor at the, I don't care anymore, position. I think it's 9th.
Are you reading these or have you memorized it?
Yes. This is another constructor which allows you to get this. And string constructor once more, get this. If we move on, number, string, Boolean function, string. And so we get a bunch of characters. I only really care about that one, to be honest, but because it allows us to make the word name. And name is fun because you can then get the name of the function. Yeah, which is different than the actual function description. So we have this, which is like, okay. Then we have this, which kind of sucks. And we have this, which is not that bad. This is this. This is how you get name. It's quite terrible. And if you move along, you can get toString. Which I'm not going to click through the entire thing. This is a function, and then this is name. So you're getting the name of the function. This is how you actually get string to appear. Because we don't have access to slice. So we couldn't do function.slice the indices we want. Yet. So this just does this. Which turns out to be this. And then you can get the curly bracket. How do we get the curly bracket? Well, you see we have those two things. The first one builds the word slice. The second one builds -1. And so if we go to this, something happened. You get slice, -1, and from there, you can do this. My color coding was wrong. This is fine. And then we can do this. And this gives us the curly bracket. That's the last element of that. Without having the need for a \n. Once more, very cursed. But now that we have an opening and a closing bracket, we can build full functions. It's fantastic. For everyone who is not, well, for me. No one else. This is the depth where you start to believe me about when I tell you that things are equal to things. Because, yeah, no one's got time to, deobfuscate all that. But this turns out to be this. And if you call this an environment, it will give you something else. But how do you call this? I haven't actually shown you how to make code executable yet. The equivalent to eval without actually having access to the eval function. This is how you do this. You take flat and then you take constructor. Any code that happens in the parentheses after that constructor is then going to build a string, but is technically a constructor string, which can then be interpreted. You come at the best time for some very cursed stuff. So if I execute anything, I can execute this new string I've just built, right? So far, so good. If I do that, I get a range error. Now, range error is a very specific error because you get a capital R and a capital E. And what do you do with a capital R and a capital E? Anyone have a guess? Anyone?
Regex.
Yes! Regex! You're getting into the world of regex. So this is how you get regex. Yes. So this gives you return regex, which gives you access to the function regex, because regex is an object. And when you use this, you then have access to these characters, which you can then use to gain access to these characters, which aren't that useful. The slash is only useful for one thing. You get a backslash. And so when you have a backslash, you can do more fun things. Such as, anyone have an idea? Screaming. It's
Escaping characters.
escaping characters. Backslash U, anyone?
The Unicode literal.
Indeed. So we can also get the common tick from all that, because we can get unexpected token. This is how you weaponize errors to actually give you strings that give you more characters to weaponize into something else. This is how bad we're at. So if you take those characters, 30th and 31st character, that's how JavaScript works, get tick and comma, and then you get into the world of Unicode, because now you can build a function which returns any Unicode character, which is A. Or, if I leave you with this is not the end of the presentation in itself, this is the middle of it. Hello world. Now, I've gone through like 17 iterations of, I don't know, like Dante's Circles of Hell at this point. So you can just assume that this is in the multiple kilobytes of data level of data. I actually didn't need to do this. Like, I could have taken the O from another thing. I could have taken the L from false. I could have taken the E from undefined. I only really needed it for the capital H, the space, the exclamation mark, that's a string, and the comma. And maybe another one. W. But here, we're all having fun here. Except Scott. So now we're going back into the realm of sanity, which is another contrast change. A few war crimes. I did say sanity, I was lying. So before this info dump, I do really enjoy a good CTF as a contributor. But that doesn't mean that people really enjoy my contributions. Case in point, Scott. So typically at the AppSec Village, I did one at RSA, maybe at DEF CON, so avoid the DEF CON AppSec Village CTF if value your sanity. Digital Overdose, community I run, Transactance, Phoenix CTF, ShellCon, etc. But how did I actually get into this? How did I get into making people question their own and my own sanity? So JSFUG actually came to me not in a dream, but as a dare. So I joined the hacker community during COVID, as one does. And that got me into all that bullshit, which got me into all this bullshit. But that's how I got started. And so we can actually really just blame Leonard for this, to be honest, because he's the one that got me into that thing. So we can just blame Leonard. So that challenge was just a text box on a web site, which did a just-in-time evaluation. So you type a thing, it runs a function with the thing you've typed, and it evaluates it. And does that with JSFUG. You enter the correct input, it tells congrats. Everything else, it goes nope. That's a pretty good framework for any kind of challenge you could write, so long as the rest of the challenge is different, nothing changes. It's a very easy thing. It's a box. You enter a text in box. So it's a very good idea. And so this would be the core delivery concept for many of my challenges. The only thing that's different, of course, is the JSFUG that was in there. I'm not pulling that because, one, that'd be boring, two, that would just not be as fun. Which is not exactly the same distinction as you think it might be. So in terms of character progression, I had a few challenges, so these are challenge names. So they're just baseline code. JSFUG does a few things. Then we had pseudo-random number generation into the mix, because there's some very nice pseudo-random number generators that you can do in JavaScript, which you call a first time and it seeds it, and then you can call any number of times and it'll give you a number between 0 and 1. But you can seed them, which is very nice. So array size variation and some fuckery with that. The Geneva suggestion, I did say this when I talk about war crimes. So UTF-8 variable names, some fuckery with XORs, yielding functions. Those are always fun when you're doing any form of debugging. And I've never written a challenge that goes through the entire JSFuck process. I've always cheated a bit. So what's next is, of course, full JSFuck, because why spare people when you could not? And so this is kind of the process for one of the challenges I've written. It's just, you have an input, it goes into an obfuscated thing, which contains a preprocessed flag. But the thing is, I don't care that it contains a preprocessed flag, because they have to reverse all the other bullshit first. And that's part of the challenge. Because when you put something in, it goes through the thing in one direction. It compares the output of that with the preprocessed flag. The only way it would match is if the output matches. Now, of course, this is no way to store a password or anything, because that's the whole point of this. It's showing that whatever you do, it won't save you from pwning it, or someone pwning it. But yeah, secret ingredient is war crimes. So, there are other kinds of challenges. Base 128 encoding uses 7 characters as a baseline instead of 6. Why not? Audio-based steganography, so CSV of audio channels, has always been a fun thing to do. Sound file where it's actually the space between the sound that matters, not the actual sound. Jitter in a channel in an audio file, which is just Morse code. Image-based steganography, which is quite standard, but hey, I mentioned Fibonacci, why not Fibonacci? Or some fuckery based off of Fibonacci. Masking, so this just looks like a corrupted image. It is in fact not a corrupted image, it is a key to a thing, which will then allow you to decrypt a thing. Why not? But then also normal pawn challenges, because why not? But also they've been done to death, and everyone always has a better idea than I do, so I might just do something original for once. And so I did mention that there was this part where it actually helped me with my reversing, and for the one I've just been talking a lot about how I make people suffer. Or how was the phrasing, Alice? The learning to appreciate? No. Yeah, you're that's fine. So it's actually nothing to do with the obfuscation. It does not have anything to do with the obfuscation, because the engine will process, I'm talking about the JS engine or the browser engine, will process the code at runtime. Which means if you know how to use a debugger, you place a breakpoint, it just does all the work for you. So for the breakpoint, you wait, you step in, you get decrypted code. I say decrypt, de-encoded code. So that's boring. Why not do something fun? Because it is in fact decoded code. And then, it's all about the logic behind that. This is where the pseudo-random number generation stuff comes in. Because you can't pre-process pseudo-random number generation without knowing the seed, which you would only get when you're processing and reading the code. But then you would need to generate an unknown number of characters of your sequence to then be able to brute force it. So you need to play with the thing as the process goes along. And that is the fun bit. So loops that do nothing is always a fun thing. So a loop in a loop in a loop that actually doesn't do anything. Because people are just going to click the next button until they hit something that works. Then they're going to forget that they're doing that. And then they're going to skip an important step. Because that's how we make people miss things. Randomization of runtime. RGs. Dynamic state changes. Things that change the nature of the document on which this thing is executing on. Those are always fun. As long as it is processed in a way that is deterministic. The deterministic random is not a word you would use in anything that actually resembles cryptography. I hope. But you can use it for this type of stuff because it isn't cryptography, it just looks like it. And then you can do stuff with DOM egress and ingress, where you just add stuff to the document object model and you pull stuff out and you start messing with things. So, of course, you wouldn't even dream of relying on this for security because, well, first of all, you'd have to be a bit broken inside. And it is also part of the objective of my challenges. To show that if you're doing something, storing something in the front end, it's always going to be vulnerable, no matter how much bullshit you put in front of it. It is still just a door or a fence, but the fence doesn't extend all the way around the park. Or you could just jump the fence. Or jump the shark. So, yeah. There's also the bit that if you're doing your usual processing of inputs, the usual AppSec bullshit of, hey, maybe validate it. Maybe strip and sanitize it. Because sure, you're looking for, I don't know, script equals script. Or script/script, or whatever. But are you looking for the automatically evaluated version of script execution? Because that too may be evaluated. Like, you're sending text, but you don't know how it's getting processed on the backend. And there are some ways of doing XSS with JSFuck which are very fun, and which, to my knowledge, to be fair, is not that extensive, are not found by web application firewalls. So you can have some fun with that and do some breakage of stuff. It may just cost your sanity and counterpart. So up to you then. And, anything that's system authentication. Putting these things in the front end, this is normal stuff. I would expect people at a conference to know not to store anything in the front end. Then again, we've all seen some horrible shit, haven't we? Client-side certs is a sequence of words I will never, ever want to hear in my life again. I've heard it once. And yeah, that's the most basic of AppSec for anything that touches a browser or an application. Because JSFuck will break through a lot of things, and you shouldn't even be relying on the assumption that someone had common sense when building it. After all, I wrote this talk. And yeah. Common sense is neither common nor sensible in most occasions. So it helps me in many places. It's helped me learn more about coding and how to build systems, even if it's to break other people. Testing things, so testing input fields, testing other things. Testing the limits of an engine, testing how much information an engine can process before crashing. Because you are technically executing megabytes of text in a system that is not designed to execute megabytes of text. Your browser is not meant to handle lots of megabytes of lots of text. Images, yes. Text executing, less so. It'll work, but, not everyone here has multiple gigabytes of RAM to allocate to Chrome, or has anything resembling not 100 tabs on Chrome. It also helps you with prototyping, because you can build things that will then be executed in some ways. Helps me in analyzing, because you start to notice patterns, like everything that is those specific kinds of text, those numbers that are being used. You start to understand how they work in the context. Not what they do, because you have to go one step further. But you can start to see that there's a pattern in these things. And it helps you at reversing. And understanding how things work is really useful to then understand how other people are breaking them to then do the opposite thing, which is fixing it. And this is where this comes in. It does come in handy sometimes. Not that often. But sometimes people reach out for me to take a look at a thing. Hi, Emily. Usually in the interesting world of phishing. Because phishing is where you would expect people to at least try to hide their traces a bit if they're doing a thing. And it doesn't happen that often that I get asked to do this because, well, my sanity is also on the line at the end of the day. So, for various reasons, we're going to be referring to a certain company by cheap named. So a friend reached out, hi Emily, and they use single-use emails for stuff, especially sensitive stuff. So when they get an email that is not supposed to be arriving at that email, it's almost instantly phishing. So it's a very believable phish coming from DHL, from a certain provider, that arrives in your mailbox, but you're not supposed to be getting this email. So what happened? You get them posing as bigger corps. Like I mentioned, DHL, you have UBS, you have a Deutsche Bank, you have crypto firms, you have a ton of bullshit. And it's a kit. Get an example. It works. You have a link. It looks believable. It comes from an address that's believable. Might be forwarded via a company, etc. And it looks believable. Like, there's no typos, there's no bullshit. It's believable to most people, or people that aren't necessarily aware of the risks, or that aren't necessarily looking. So, the technical overview of it is just it's a multi-stage job. You have anti-analysis features, which actually got the best of me, so yay. Yay them. And a form of sinkhole. So if, I'll get into it, but if you don't meet their risk model, they will sinkhole you. So this is where you start to have threat actors with threat models. Is starting to, and you've always had them, but as part of just a phishing op, that starts to be a little bit interesting. So your process is just, you get your email, click the link, you get thrown through a redirect chain. Pretty standard shit. You have a payload assembler, then you have a payload with anti-analysis features, then you either get sinkholed, or I presume you get redirected to the correct login page for DHL, for a Netflix, or bullshit. Then they capture credentials, and life is fun. The bit that's interesting is the anti-analysis here, because that one was extremely sophisticated. So your stage 1 is just logical obfuscation. So you have some array which then gets accessed in a certain way, usually in a very cursed way. And you have a magical string builder. We'll build strings using your character set here. And your payload is immediately evaluated using the eval keyword. So they're just cheating a bit, but eh. And you get things like that. So they actually had this vaguely... it's something I've seen in various places. It's just the use of the function hunter. Not all things in hunter, like HUNTR, all variables, are used. But it's not exactly a signature, but it's not a signature. And you have this thing where they give you like a massive string, and they try to decode it using a bunch of parameters. And this is where it gets fun. Well, fun depending on who you are. So you have a string, your R string, at the beginning, which is basically an accumulator, which accumulates your deobfuscated stage 2 payload. You have the S buffer, which is just a thing that will map characters until you hit a certain character. And then you have another buffer, which is just going to, another loop, which is going to iterate over that buffer and convert it to a number, which is then going to be subtracted 45 from, which is then going to give you an ASCII character, which is then going to be interpreted. So you have this, for example, so you have your first characters of the sequence, or some characters in the sequence. So your first pass does this. So far, so good. Another pass, another pass, another pass. You get like 8 or 9 executions before you get to 2103. 2103 isn't that interesting of a thing. Won't give you anything interesting. But the rest of your stage is what takes this number and does something with it to convert it to ASCII. So your first bit is you take each one of your character. So in this one it would be, so 2103 would be the 3103, third character, power 4. So if we have powers, we're talking about things such as base 4 encoding. This is where it starts to get fun. You get the numbers, with base increasing, you get a value, 147. Okay, what are you going to do with that value? If you have a payload, which is a certain length, very long length, you can break it down using T as the separator, convert it the first time around to a sequence, break it down to a pre-ASCII value, Subtract 45, which is a random value they've chosen for this operation, and you start to get something fun. Function as a word built from another string. And that function is automatically evaluated. So unless you're going through the process and you've already removed the eval keyword, this thing's happening. You don't have a choice. So one of the fun things when you're reversing is that you can just say, hey, eval is being renamed to something else. Fuck you. Eval does not exist in your context. This will break a few things, but this is the kind of breakage you do want, because you do not want something downloading shit on your browser. Now, once you have this, you get to your stage 2, which is your actual function being executed. And this just checks that certain functions actually do work in the browser you're trying to do the analysis from, or that you're just accessing the phishing site from. Whether functioning proxying works, which is a feature in certain browsers. Whether worker threads work. Whether iframes work the way they expect them to. Whether the canvas works in a way, or if it's using a fake canvas or an emulated canvas. Because this allows you to basically build a tree of your browsers to determine a specific kind of browser you would want to target. Testing whether or not it handles orientation. Are you on a phone? That they'll be able to find that out because it is a core function of your browser. And this produces a fingerprint, which is then encoded and sent on, and this is where they do their threat assessment of you as a potential phish victim, which is a bit weird. So this is a fingerprint that gets sent out, and the response is either a URL with then your phish kit, or a sinkhole, which then sends you to nowhere, and then you have nowhere to go. And you can just close the tab and be done with your life. So to basically close this off, it's a very sophisticated large-scale phish, which did affect a bunch of people, because it was based on a certain company that got breached, which is not cheap names, but another one that they use as a provider. Very strong anti-analysis feature, and the way this happened is SendGrid got breached in 2022. And the most reasonable assumption, I'm not saying that it is a guarantee, is that this entire group, SendGrid, which is owned by Twilio, which is owned by Okta, got all of these emails from cheap names based on their mailing list system, which would then use SendGrid, which is an assumption I'm making, but it is also what Twilio's actual report states, that it might be Octopus that did the actual breach. So it is an assumption we're making, or I'm making. So in conclusion, JavaScript is a fun language you can do a lot of shit with. JSFuck exists, and I learn things by doing the things. So you don't get to this cursed level of, I would do this for fun, without actually doing some of the cursed stuff. And that actually helps me on the side of the undoing. I'm not a threat actor. CC and just here are my socials and blog and stuff. And that's my time.